That was a big hit. Saw a lot of chamber members. Wayne, Ronaldo,
All right.
bunch of them.
All right, well, let's go ahead and do this. Good morning, everybody. Thanks for joining us today. I'm Mark Gemignani. I'm president of Dominion. We're leaders in building and renovation. I'm the chair of the Construction and Development Council here at the Miami Beach Chamber of Commerce. Also introducing Javon Tillett, chair and president of East of Collins Expediting. We've got an amazing program here for you today. It's a continuation of our series on safety and longevity of our local structures. And today we're going to hear about some research and development that's been done and continuing on how best to understand and deal with our local coastal structures and how they're affected by the environment. But without further ado, I'd like to introduce our speaker so we can give him as much time as possible. He's got some really great insights and thoughts and data to share. Our speaker today is Dr. Altarod Azinamini.
Yeah.
Did I get that right?
Yeah, I'm going to let you say it. So.
I said it with an Italian accent. Dr. Altarod has been here at FIU for 11 years. He's the Vasant Surti Professor of Civil Engineering. He's the director of the Moss School of Construction for Infrastructure and Sustainability. He's the director of Accelerated Bridge Construction, University Transportation Center. And he's the director of Preeminent Institute for Resilient and Sustainable Coastal Infrastructure. Prior to that, he spent 21 years at the University of Nebraska, where he was the Distinguished College of Engineering Professor and Director of National Bridge Research Organization. Earned his degree in civil engineering from the University of Oklahoma and has his master's and PhD in civil engineering from the University of South Carolina. I'm going to give you a couple bullet points on his career from his bio, which is extremely long, and then we'll get moving. So Dr. Aziza Namini developed bridge engineering products and systems that are being used all over the world. He's led the development of the first and most comprehensive worldwide document devoted to the service life of concrete and steel bridges. He's published more than 200 local publications on the subject. He's received the White House Champion of Change Award for Transportation Innovation in 2015. He's got the Special Achievement Award and also multiple Bridge Innovation Awards from the American Institute of Steel Construction. He's also served as a consultant on major bridge initiatives all over the world. So without further ado, I'd like to introduce the doctor to talk to us today. Thank you very much.
Thanks. Thanks. And thanks for inviting me. I'm excited to share some of the results of some of the work that we've done, especially in the light of some of the challenges we are seeing with our infrastructure nowadays. So let me see if I can get my... All right, I think we are on, I believe.
Yep.
Okay. Let me do something. I need to, when I share it, I need to share the sound too. Right. That way, if I have a video, they can hear it. All right. So let me put over here.
I want to minimize the right side of the screen with all the faces so that it's not, there you go. There you go.
So before getting started, I also wanted to kind of tell you who we are, what we do at the university, so to introduce you to, and also tell you who do we work with, and then I'm gonna jump into the.
I don't think it's showing on Zoom because.
Oh, it's not.
You may want to unshare and share them. That one,
Okay, let me share.
Yeah. And then do this.
What like this?
Yeah, exactly.
Is it showing now?
Now we're doing.
Well, it's showing the. Let me.
Yeah, it's showing the next slide.
Is it better now?
I'm only seeing this. Why don't you
Just click duplicate slideshow.
No, share it again.
Okay. Okay. I'm gonna put on the PowerPoint presentation.
There we go. It's okay if the next slide is showing.
It's showing both of them.
Yeah, it's fine.
Okay. Is this fine?
Yeah.
Okay. All right. So, since 2013, we received the funding from the USDOT to, the funding from the federal government is about $1.5 million a year. And it's very competitive. There was more than close to 200 proposals, and then we were selected to work in the bridge engineering. And we've been continuously funded since 2013, and the recompetition actually is coming up because the infrastructure bill that passed, so there's going to be recompetition again. So FIU is the lead, and we've got the Iowa State, University of Washington, University of Oklahoma, University of Nevada, Reno as a partner university. Some of the technology that we are developing, that we have developed, even though has application to the bridge engineering, but also has a equally applicability to the buildings, and especially with some of the challenges we've seen after the Champaign Tower collapse. So just to give you an idea that who we communicate with, what we do, I always say probably we are the best kept secret in South Florida, and I don't know what the reason is. I think probably the reason is that we get so much federal funding that in the past probably we have focused on addressing the problem at the federal level, at the national levels. But recently we have started working with the local people, with the cities, and just very recently, especially after the Champaign Tower. And we hope that to increase that interaction that we have with the local industry, and so that, I mean, everybody else around the world in the other states, they are taking advantage of everything we are doing. So it's time maybe that our own people in our backyard do that. So this is it. Very warm welcome to more than 600 people that are attending the 2017 National ABC Conference. You know, it's wonderful sitting here and seeing all these bridge engineers in the house.
Should we press the sound?
And if not, that's okay. Don't worry about it. I hear it. Maybe this one.
Just try it now.
That's all right.
Yeah, I think you maybe had it muted. Yeah. Wait, or was it this one?
Oh. Isn't that great? That's okay.
It's a huge honor to be here.
I mean, this
It's
is
an
a
honor
small
to share the
video,
stage with some of my
short
USDOT
video.
colleagues.
That
My
conference
hat
is
is
actually
off
like
to all of
started
you
in
in the public
2014,
sector. So I think there's an
15,
energy
17,
building in the
and
U.S. I think
19.
it's building within
The
your
next one is gonna be
organizations, it's building within
2021.
ours, it's building within
And
industry.
ABC has
really
been
becoming
an emphasis area
I
for
would
us
say,
for many years. So ABC, it meets the needs of
probably the
of our
second
ultimate
largest
customer,
bridge
the
engineering
traveling
events
public.
So
that
we
can
see
take
our
place
research
in
as
the
focused on innovation and driven toward providing solutions to national and global challenges such as transportation, health, and environmental challenges.
Where else would you want to be in December? Early December and Miami culminate both as a good time and location for a venue like this. And
it's very nice to see some young folks get involved with our industry, and this forum has offered a broadening of their experience.
We have been very fortunate that in this conference we have about 50 different companies they are exhibiting, showcasing their products, their services.
Well, the workshops are good because it's a longer session. You get 4 hours of just talking about, certain aspects. So you get to find out what the newest things are.
Because it's so content rich. I mean, there's 119 presentations, there's 11 workshops.
For me, it's the collaboration and partnership that we can gain from one another.
The experience is great because there's so much innovation. We're constantly trying to improve our program and come up with new innovations. So just coming to a place like this really, opens our eyes to what's available countrywide.
The conference is extremely well organized. They cater to a very large cross-section of professionals.
We also like to recognize the best ABC projects. During the general sessions, we were able to recognize several signature projects at the national level.
We need to energize the American people's imagination about what infrastructure can do. We need to reinvigorate how important infrastructure is for them. The vast majority of the American people think that we have the best infrastructure in the world, and I think we did, and I think we can, but I don't think we do.
I'm very pleased to hear that in 2019 conference, we're going to be entertaining.
So that's it. Just so we are in communication with almost all state Department of Transportation on a weekly basis, and close to 30, some of them actually they co-sponsor actual conferences. So the next one I'm going to give you some information. It's in the this December, but it's virtual. December of 2022, we are going to be face to face back in IDGC. So back to ultra performance concrete. UHPC is originally actually was a product. It's a cementitious based product that was developed in France, Lafarge, and then they came to the US, and there is a proprietary version of it that is being marketed, and it's really opening lots of opportunity for us, both in the buildings and the bridges. And I'm going to show you some idea. Now, if you want to know the recipe, if you want to go and make your own UHPC, I'll give you a copy. I mean, it's no secret. In fact, what we are doing, we have developed a non-proprietary version of this UHPC. And our idea is that we want to make this available to everyone because we are more interested in application of it, not so much on the material aspect. The non-proprietary version that we have developed, the cost is a fraction of a proprietary. And I'll give you some idea. The regular concrete and cost, let's say, about $200 per unit, let's say. The proprietary version of the UHPC that's in the market is very expensive, but you don't use as much. Okay, that's a big factor. It can go up to $4,000, $5,000. But the non-proprietary version that we have, you can be at $800. So that's significantly lower, and that's we have developed it. Other agencies, other institutions have developed it, and I think within the next 5 years, it's going to be, you're going to see a price of the UHPC produced around $800. Now, for the building application, later on I have, for high-rise building actually, I'll show you some example how much economy you get if you use the high-rise buildings. You can bring the cost down because you don't need the fibers. The major cost of this material, because it's expensive, is fibers. But in the high-rise building, in most elements, you don't need that. Then you can bring the cost down to almost $350. And then the economy that you get is significant. So, just to give you one idea, okay, forget about lots of stuff in these two slides, but on the left-hand side, you see a chart on the right-hand side. The horizontal line basically means time, like let's say a number of the days that you got a piece of a concrete that is exposed to a very harsh environment. The lower you are on the vertical axis means that it's more durable. The right-hand side is the UHPC. So UHPC really, nothing penetrates through it. That's what this slide is trying to say. This is a little more a good one. We have very recently developed a non-destructive techniques that you can, in 10 minutes, you can compare the durability of any concrete. And what it is, basically, we take a cylinders, and then we simulate having that cylinder being under 400 feet of ocean water. Now, again, it's a patented product that we've developed, but it's a very fast, quick test. For example, I can go to a building, and I can do this test in, let's say, 10 minutes. And right now we are developing a reference basis and say how, for example, the quality of this concrete compares to what else that we have. Over here on the right-hand side, you see a regular concrete that we use in the construction. On the left-hand side, you see UHPC. The right-hand side, the normal strength concrete was simulated being under the 400 feet of ocean water for 10 minutes. And you see the ring above that, that means that the water seeped through. The left-hand side is the UHPC. And that was simulated also being under the 400 feet of water, but for 30 minutes. Absolutely nothing went through it. So this is how durable this concrete is. So if you have, for example, let's say a building, high-rise building, that you know that the parking garage is going to be basically soaked in it's going to be a pool, swimming pool when you have a king tide. Just cover it with a ½ inch of this material, 1 inch of this material. Or if you have a column that you know that, for example, all you need for fixing the building is, let's say, for example, you need to just patch it up. We got to use this concrete. The balconies. I mean, we know that there are problems with the balconies. For the life of me, I don't understand why we don't use this, for example. I mean, the way we inspect the balconies, I don't believe it needs to be improved, because you have to see inside of it. What's outside is not going to tell you anything what's inside of it. So this UHPC really is, I would say, the best application is really for the retrofitting. It's not building something new, but it's retrofitting, upgrading the structures. You can upgrade the structures, bring it to the condition better than the original. Okay. And just to give you an idea, I mean, this thing is, if I take it and let's say I have a damaged area and I patch it with the UHPC, the service life, how long it's going to last with the UHPC is going to be 100 years. With normal strength concrete, it's 30 years. So which one would you use? So at least if you've got buildings, structures close to shoreline, close to ocean, we really have to use this kind of concrete. You cannot increase the durability by increasing the cover concrete. So a couple of years ago, actually, I went to Switzerland. I have good friends, and I always, of course, look for a reason to visit my friends in Switzerland. And they've used this kind of concrete, UHPC, for a number of years. And they have upgraded the structures. For example, let's say the Venetian causeway bridges that we have, right? We can upgrade those bridges at the 10% of the cost of the replacement and bring them up to condition that is even better than the original conditions with the UHPC. I'll admit that. The Venetian causeway bridges, that kind of stuff, that, for example, the superstructure part of it. And I'll show you some of the technology that we have developed that you can achieve that. At the 10% cost of the replacement of that structures, you can bring it up to speed. We've done some experiments. For example, we took the white area that you see, like a T section, like a damaged, let's say, structures, and then we wrapped it with a 2-inch, 1 inch of this material. And that, if you do that, you can increase, you protect what's inside. We use that as just a formworks. And the capacity of this thing becomes 2 times the original conditions, because this material is so strong. This material, by the way, I forgot to say, the compressive strength is about 20,000.
What makes it so strong?
That's because the material it's a very dense, compact, and it has a fiber, it has a ductility. You can bend it actually a little bit, this material. So it's very high strength, very durable. And you don't use too much of it. Okay. For example, we took this, and it flows. If I just for experiment, we built a formwork that was made out of a glass, basically, and we put that damaged that T-beam inside of it, and then we pour this UHPC. It just flows because it doesn't have any gravels. It's very dense, compact. It has a very low water cement ratio. It's 0.2. You're functioning 0.2. And so you can take any structures that you have, you can just have. The other thing is that for a hardening of a structure, for military application, it has extremely good. It's very, you can, for blast resistance, for example, this concrete has, because it's got lots of fiber, it's very high strength, it can take lots of energy without really breaking or anything like that. So, and this is anyway, we've done lots of testing, and this is, before retrofitting, you see, just look at the level, let's say, this is you go from here to here. Just by putting about 1.5 inches of this material and putting a little bit of steel in the bottom, okay? That's why in the Europeans, my good friend Eugene Burweiler in the Switzerland, he says, I don't want to call it a retrofit, I call it upgrade, because after I'm finished, my structure is better than the original conditions. The other thing we are doing is now, this is a new, it's not in the US yet, but we are doing a shotcrete with the UHPC. So what we do, let's say for example, you have a structures, you just go with like a hose, you just spray this material. We are playing with this now. I think we are going to be ready probably within the next, we are almost there. Okay? We are almost there, I think maybe in 6 months. I mean, we've been playing, we've built our own, basically the pump and the air compressor. And then the nozzle is a customized nozzles that we built. And this is let me show you there. Basically, you just spray it. Now imagine now you have a Venetian Causeway bridge, let's say. I go outside of it, I cover it, and I spray it. How fast it is.
They've not approved it first?
Company that has the right. Morgan, do this one. Morgan, go. Yeah, go ahead, do that. Stop selling the material to us like the way that we are getting into this move. So, in the next 6 months, we're going to be basically having this. But within the next, I would say 6 months, we're going to be able to get this technology, and I think it has lots of applications because you don't need any formwork. You just go to the site and you just spray this material. Now, shotcrete using normal strength concrete has been done. What we have not done is the shotcrete with the UHPC. The other area, for example, that we are looking at, this is not, I mean, there are lots of, you know, the pipes, for example, the pipes, one of the reasons, for example, you see all these pipelines, they're bursting and then the flooders, the water is just seeping through. Now, there are also lots of culverts that many states have. For example, one state in the Northeast has 500 culverts that they need to retrofit. So we have developed these robots. Right now we are buying all these are customized made. We don't buy, we build our own robots. Basically it goes in and it has a basically nozzle that goes inside and then just sprays it basically inside. And I think probably we are about 6 months away from doing the first experiment with this. We've done some experiment smaller scale, but this one is going to be full scale. We can retrofit any diameter really pipe with this. Again, this kind of stuff has been done with normal strength concrete, but not with UHPC. So we are really taking all these technologies and applying it with the UHPC.
Could it be used for pylons? My dock, I know nothing about this, I'll admit. My dock, there's wood piles, and then there's concrete that was poured around the piles to protect them.
Yeah.
Could this be an application around that concrete to give it a longer life?
Yeah, it is. I mean, we've done, in fact, I had one student, PhD student that just worked on that, and I'll show you actually some of the work. But we can take columns, let's say. We are actually retrofitting wood columns, the piles, basically.
Yeah, that's it.
Timber piles with rapid with the UHPC, and there's a couple of things you got to worry about because the timber expands and contracts because of the moisture content, and so we have a solution for that so that doesn't affect the cover. But you only need an inch, inch and a half of this material, wrap it around it, and then you're basically done.
Question for you. So
Yeah.
normally on a building that's failing, the concrete failing,
Yeah.
it's failing because the rebar inside is got rust and is expanded.
Right.
You still need to go in and do those repairs to the steel before you apply the product.
Very good question. Okay, what happens when we wrap the structure with this material? It chokes it. In order for corrosion to progress, you need to have a water and you need to have oxygen. When you wrap something with this, what we have found out is that the material, you don't need to remove all the contaminated concrete from inside. Because once you wrap this thing, this chokes the stuff and then stops the corrosion. Okay. With normal stem concrete, you cannot do that.
That's huge. Yeah.
With this one, you can. In fact, and all I need is just go 1 inch beyond the reinforcement, and what's inside of that column, let it be.
And is this like an approved method for concrete restoration so that you avoid having to replace the
I mean,
rebar?
these are not. There is no body to approve or disapprove. It's the cementitious materials. Okay, you are not gonna, in any time in the future, you're not gonna see, for example, let's say American Concrete Institute to say that I approve or disapprove. I mean, they're not in that business. Okay, but it's based on, it's something that people have used in the Europe. Okay, and now we have taken it to a different level over here. And there are lots of information available that shows that it works.
So the trick is to get the structural engineering community up to speed so they understand that it will work, so that they can
Bridge
sign.
engineers,
seal.
the bridge engineering community are very well familiar, but the building communities are way behind. Most of the building community don't even know what the UHPC is, okay? But the bridge community is very well educated about this.
I should ask Yosef. Is Yosef still with us?
Yes, he's there.
Yosef, you there?
Yes, I am.
I'd be interested to know your experience with the
UHPC.
UHPC.
I am aware of it. I haven't used it.
Yeah, it's in the building they've used for the cladding, non-structural element, but not the structural element, unfortunately.
And Yusuf, what's the reason as to why you have not used it yet?
I understand the the familiarity of the bridge community with this, but I guess as an industry, it just hasn't been used. I mean, I don't think we have contractors that have used this or qualified to use this. I'm not sure if ACI has any standards or publications for this, because that is, one thing that we use as a guide. It's not a code, but we use as a guide for use and for applications of buildings. And I'm also not sure if ACI, and Doctor, correct me if I'm wrong, but does ACI have any publications?
ACI is working on it, but Federal Highway Administration, if you go to Federal Highway Administration, they do have standards, but it's more for the bridge engineering, not for the buildings.
Correct.
But the ACI is in the process of trying to develop. Now, ACI, of course, they have provision for high strength concrete, but in most cases they limit the strength to the 10,000 psi. But there is no standard in the ACI specifically for the UHPC. But if you go to the bridge industry, Federal Highway Administration, Ben Graybill and that group, there is a ton of materials out there.
We're very notorious for being slow.
No, it's just I think that I'll tell you one thing. Let me tell you why it is not taking off. Has not taken off. Again, I won't name the industry, but there is a company that has a proprietary. Okay, and the material. Anytime we have a tendency that anytime we put a name to a material, we kind of shoot ourselves in the foot, and becomes a new technology. This is cementitious material, right? And the contractors don't want to take a liability, so they say, well, I mean, this material, how about if I mix it and something goes wrong, who's going to be liable for it? And then the company that has been marketing it has been using that as a, I think, scare tactic to say that, hey, I mean, if something goes wrong, I mean, you're going to be liable. And several of us at the universities, basically, that we have developed a non-proprietary version because we want to make it available to everybody. We are telling everybody, this is not a brain surgery. The material is there. It's very simple to do it. Graduate student can make it. You can make it. And the variability in the property, if you do it right, it's not that much. And hopefully, I mean, that's going to solve it, okay? But like you said, I think the bridge industry, the bridge industry is way ahead. Building industry is, they have not cut it.
Doctor, you were showing us before the impacts of the water and the concrete being underwater. Yeah. What about when it's underwater and then exposed to air, and then underwater and exposed to air? Does it have the same?
Yeah, it's the splash zone. No, it's basically, I mean, it does.
Still superior.
The freeze thaw, there has been some testing on the freeze thaw. For example, there's the standard ASTM freeze thaw testing. After 365 cycles, there is no degradation in the strength of this concrete. It's amazing. Okay. Another technology that we have developed, let's say, for example, this is again for the bridge industry, but it has application to the buildings. The formworks, we are eliminating the formworks. So we are using as you see, for example, we're building the formworks out of this material, and then you can take it to the side, put the reinforcement, and then pour it. Okay. So in the bridge industry, I mean, this is how it works. Basically, you put those shells, and then you got it, basically your structures. We build, you can't see it, but these columns, only the shell is a UHPC, inside is the normal strength concrete. Okay. Now what we are doing is again, you've caught me in a good time. Within the few months, I mean, we are working on the 3D printing with the UHPC. Mm-hmm. So we're going to be printing very soon that is column that has about 10 feet tall. So you can print these things now. We are moving to the printing, both section, horizontal, and the vertical elements. This is one thing that was printed with the UHPC, basically.
What's the benefit with the printing versus just your normal?
Oh, it's just a formworks. You can print the formworks with the 3D printing. You can do that 24 hours. Robots, you don't have to pay overtimes. So, it's, 3D printing, automation in construction is coming, and it has lots of different applications. So it's one of those things that it's here. You get the higher quality, and I mean, if you can, let's say, for example, if you have in the case of the bridge, let's say if you have a bridge that has let's say 20 spans, there's so many columns, so many elements that can be, it's repetitive, and if you can print all those things, you're in business now. Right? So the 3D printing is another. Moving on, another things that I wanted to share with you. We've developed technologies that this might be of interest to some of you guys, that we can borrow from the bridge. We've developed technology to detect the corrosion. So if you have, let's say, a parking garage, if you have columns and you don't know what the condition of the steel is inside of it, we can use this method to detect balconies, for example. Balconies, if you have the balconies, usually there's the post-tensioning rods in the balconies that is holding basically the balcony. I have seen some people actually, friend of mine asked me to look at the report that was given for inspection of a high-rise building. They had a problem with the balconies, and so what they did is I looked at the report, but there was nothing in there that the inspection said that, okay, I know what's inside, the condition of the post-tensioning rod. You have to know that. If you don't know it, you can see the end of it, you're not doing anything. In fact, you're covering the something that may cause more problem. So this method, which is a magnetic flux linkage method that we've developed, it's based on the basically magnetic field. Magnetic field changes when the steel loses. So we have a complete device, the complete equipment. We've done this thing for many, many years, and with a good friend of mine, Technical University of Berlin, we have basically perfected this technology. We've tested on, I'm going to be moving a little bit faster, on some segments of the bridges that we brought to the lab. We've tested in the labs, okay? So we are able, basically, you put any kind of rebar that has any elements of the corrosion, and we can, for example, we can tell you where the corrosion activity is, and we've got basically the information that we can, with confidence.
So, Doctor, as a building contractor, how can we access this technology?
I'll tell you in just a few minutes. That's a good question. I mean, we are open to suggestions. But we've tested basically bridges that they actually went with the borescope. They looked at they looked at the condition, and we did the test. We compared with the borescope, and we were able to basically match the information. We didn't have the borescope data, but we basically, and so we are able to say where the corrosion is. Okay. Answer the questions. This is a proprietary, basically, know-how, knowledge, and so to the university and to the college, we are in the process of establishing an LLC that provide this corrosion detection, basically, and we are hoping that to take off again fairly soon. But it's not really something that you can give the device to somebody and say, go do it. You have to have a trained eyes. You have to have it basically use now artificial intelligence to detect basically the corrosion and all that. But it's there. So we can penetrate through about 20 inches of the. So if you have a steel element that's 20 inch from the surface, we can scan it, and we can kind of see what's inside. What we've been able to do now is that there are all kind of other reinforcement in the structures. So we can zoom in, basically like MRI, we can zoom in on the area that we are interested, basically.
Is that basically what it is, MRI, magnetic resonance imaging?
Very similar to that, very similar to MRI, very similar to MRI. Now we are doing these things, for example, in the case of the bridge applications, because it is very difficult to reach the structure. So we are using basically drones. We are building our own drones that can go attached to the structures and then walk. This could be a side of the buildings. It could be a columns or whatever it can. We've got devices. The vertical surface and has the sensors like the scan, basically the area. So we have lots of toys that we play around with. So this is just one of them. I mean, there's different versions of it that we have. Lab.
Downtown. Are they using UHPC?
We are actually, I've been trying to, are they using a UHPC unit? To my knowledge, I don't think so. I don't think so. I don't know. I haven't been involved with that. That's a good question.
In general, on the long term, the UHPC has much lower maintenance, so it's
once you cover it, I mean, there is nothing penetrates through it. Nothing penetrates.
So, could you speak to us about at the legislative level, I mean, why is this not a standard? Why is this not a requirement for all buildings?
Let me answer you to these questions. I think after the Champagne Tower collapse, okay, I think, in my opinion, I think we need to develop what's called the building management system. When I say building management system, that means that we need to look at the way we inspect the buildings, who should be inspecting the buildings. We need to have a protocols. You have to develop a system. You have to provide the information on how to retrofit things. And there maybe the UHPC can come, but I don't believe this. We can just take a UHPC and say this is the solution. I think we've got a much more bigger challenges in hand, and that is to, I mean, just take it, for example, the approval of the plans. Just take it from there. I mean, approval of the plans. I mean, when I looked at the Champagne Towers, okay, I noticed several things. Of course, that was designed back in the 1971. The shear walls in the, I mean, you don't see in one direction, there is a little bit of a shear wall. In the other direction, there is none. And the foundation is not tied together. So there is an ununiform settlement that can take place. Some of the detail, of course, was old. The slab at the pool level, there was no expansion joints between the slab at the pool levels and the building itself. So pull the building. If there was just expansion joints, that collapse would not have taken place. So there is an approval process of the plan itself. I think it needs to be done. Now in the West Coast, they do it something differently. In the West Coast, for example, there is a board, there is a panel that sits down with the city, and then they look at the plans and they go through the approval process and all that stuff. I think for certain buildings we need to do that. So it goes way beyond that. I don't believe just that, but certainly for retrofit, yes, UHPC is a material. In my opinion, for the material for retrofit, we've got to use that. For the certain parts of the buildings, we have to use this thing, because you cannot make the, let's say, a balcony durable against the seawater, but if you cover these things with these type of materials, then you can really prolong its life. But it's the question you're asking is demands a much more.
It just sounds almost like negligence for a developer not to use it. You know?
It may be one of getting permits approved. You know, you still have to go through government regulations, get approvals, and if the permit community doesn't approve it, then you're using something that they're not going to sign off on. It doesn't go anywhere.
There is no really
inspections. If they're going to come out and do an inspection, say, "What's this? What are you doing? Why didn't you do the rebar?" I don't have to. I'm wrapping it tightly.
The building permit process is really for like almost like means and methods. The actual material doesn't really come into the permit process except for very specific materials like windows that have product approvals.
But let's say they go to a building inspectors and they see the rebar, and you said, well, you really wouldn't have to repair the rebar. Was Mark's question, because if you wrap it tightly, you can. So if an inspector comes out and says, okay, all that rebar's got to be replaced, and you say, no, not going to replace it. I'm going to wrap it. And they go, well, we're not going to sign off on it.
Yeah, it's typically under the purview of the structural engineer, the engineer of record. He's the one who typically does the inspections and approves
that's part of the inspection is that, for example, nowadays, let's say you go in and then you see it, for example, there is a signs of, for example, let's say some problem, let's say in a column, let's say, for example, the door is not shutting down, things like that. I think one thing that we have to do is find the root cause of it, of the problems. So another way, just by patching the columns, you may not solve the problem. If the problem is a foundation settlement, you've got a more serious problem. If the foundation, there is no grade beam in the Champagne Tower, there was no grade beams. There was in fact, the slab seems to be a couple of feet above the footing, and the plans doesn't say anything. We have modeled that whole building, by the way. We have modeled that whole building now, but we've gone, it took us 2 months to read the plans. I mean, there's so much information that is missing. There's contradictory informations. So there is you have to find the cause of the problems. And then you can say, okay, I'm gonna do it, retrofit it this way. The other thing I think, now that we are discussing the, let's say, the inspections, I think the most urgent item is to spot check the buildings that are 10, 12, 15 stories, not very high. I think the high-rise, good engineering have gone into it. The ones that probably needs to be priority 10, 12, 14, 15 story buildings, I think you can go look at the plans in 1 hour. You can say foundations, everything's tied together, there's a grade beam or there's a flat slab or whatever you have, so there's no uneven settlement, so that's good. Shear wall, I've got a shear wall in both directions, they're symmetrical, it's not going to cause any torsion, great, that's great. And there's a pool area, things like that, the structure is separate than in the garage or pool or anything, I'm fine. There's no red flag. When there's a red flag, then you go to the next step. Now I'm going to do a little more inspection. I think that's what we have to do. That's it. You screen it. You screen the plans, and then you identify the buildings that needs to be inspected a little more.
Half the problem with that is those plans no longer exist.
Yeah.
These older buildings, if you go past 1990, it's very hard to come up with legible plans.
Yeah, no, we find out but there is still there. Champagne Tower was built in 1971, so based on the 1971, it was built in 1979, 1980, but still there's the plans.
Since we're talking so much about Champlain Towers, obviously, it's a good point, a good time to remind everybody and invite anyone on this call. On Thursday, December 9th, at 9 o'clock in the morning, we have our next condo committee meeting. It's probably the next to last meeting that we're going to have. And we're going to try to come up with some recommendations that we can put forth to the state, to the city, about things like interim inspections, reserves, whether they should or shouldn't be required, or percentage of reserves. We have a whole list of things we're going to be looking at.
There was something mentioned, I think, at that condo meeting where they wanted to require developers to provide a maintenance plan when they turn over a building, and explain all the different facets of the building that need to be maintained and when and how and et cetera. To my surprise, my sister just bought a townhome from Lennar, new construction, and they have provided a maintenance plan for the building.
Yeah.
I was actually pleasantly surprised to see that.
The one thing that would be a good practice, we are not doing that. I think the structural engineers who, of course, these companies come and go, but the structural engineers who design the building, they need to be involved in the life of the buildings. They need to, at the stage of Europeans, in the case of the bridge, in the Europe, they have something called a interesting birth certificate. So when they hand in the bridge to the owners, they've got this document that they take a material that has built material, and they record. The structural engineer says in 5 years inspect this part, and so they specify. For example, so many years replace this part and so on. So at this stage of when you turn in basically the structures to the owners, you provide these documents. It's like a birth certificate that keep tracks of everything.
That's
interesting. Sounds like when you lease a car. I just took my car in, and it comes with the lease. You got a 15,000 mile service check, and they do whatever needs to be done.
Exactly.
You should have some kind of a warranty that you price it in. It's included. Right. Now I'm going to do this every 5 years. I'm going to check out your.
That's what. And then I think that's why I say when somebody asks me a question, what we need to do, I say we need to develop a system. Call it building management system that has everything in it. It has to have a finance section. I mean, you got to work with the attorneys, you got to work with everybody, with the bankers and finance people, and develop a system that's sustainable. Now, the good thing is that in Florida, we are way ahead of everybody else because of the hurricanes. I think now, one thing that's very interesting, if you guys, I don't know, but in the case of the bridge industry, there's a lot of check and balances. you've got the US DOT, you've got the Federal Highway Administration, you have the State Department of Transportation, that they all have responsibilities, check and balance. Okay, Federal Highway Administration checks everything that the state does. When it comes to a state, there is no one national agency you can say that's responsible for buildings. There is none. That's why the states are up to state. That's why the state basically is really responsible for their own building code. Now, there is a national building code, I mean ACI and AIC and all that, but those are just a material aspect. They don't tell you everything.
So Doctor, are you or the university, based on all this research and all this knowledge, going to considering formalizing any guidance for our local building community and weigh in on this conversation?
We are trying to work with the community. It's myself, and then we've got two professors of practice that I'm working. Basically, three of us are working together. Joe Colasso he's in his 80s. He designed the John Hancock building, so he works with us. Larry Griffiths designed the Dallas Cowboys, the roofing structures, and the Marlin Stadium, the roofing structures. So we are working, we are meeting with each other, and we have enough information. I think we can help the community. We need to see how we can, how to share this information.
Yeah, how can we funnel some of this information and knowledge into this conversation?
I think joining us for that meeting next week would be good. We have the
December 9th. If you can join the meeting, that would be great.
December 9.
I'll try December
9 in the morning. We'll send you a calendar invite.
We have our that conference goes from 8, 9, 10. I'll see if I can maybe take off 1 hour if they don't need me. It's going to be right here in the Miami Beach. Actually, we're going to be broadcasting. But no, we have modeled that entire building. We are looking at our focus is not to find what caused the collapse of that building. Our focus is to see what changes we need to make to our building codes so this thing doesn't happen. Mm-hmm. For example, I'll give you one example. And I'm looking at that actually. I have a PhD student working on that. In the West Coast, where the seismic events take place, we know that, for example, that we need to design the building so that even during the earthquakes, 8, 9 Richter scale, it can sustain damage beyond the repair, but it should not collapse. We don't do that in the non-seismic area. We need to do that for the buildings by the ocean.
Yeah. Well, as interesting as this is, we're pretty much out of time. Do you have any closing things you want to mention that we didn't get to?
No. I'm just gonna show you just for the people who are building with myself, Joe Colasso, and actually Larry Griffith. We designed this 42-story building with the UHPC. So architects, these are we have lots of data. There is a big economy. The economy was about, you can reduce the cost by about 10-15% in this case. Okay. The final thing I wanted to tell you that if you guys are interested to learn more about the UHPC, we have a virtual conference that's coming up. Okay, December 8 through 10. You can go to our website and register for it. There is a workshop on UHPC, and we've got some speakers from Europe. Eugene Bruweiler is probably the most knowledgeable in the area of the UHPC in the world. He's going to speak there. We've got other speakers from China, and so on. It's a very good conference if you want to learn to see what everybody else around the world is. This conference, intentionally, we focus on the international. We wanted to bring to a consultant in the U.S. We wanted to show them what else other people around the world are doing. Okay? So anyway, go to that website, avc.utc.fyu.edu. Okay. avc-utc.fyu.edu.
Do you want to see if anybody has questions in the chat?
Yeah, sure.
Yeah, we're out of time, but we could take a couple quick ones.
So, yeah, someone wanted the conference information in the chat. So, Can you
Yeah, let
copy
me-
and paste that? Is that something you can copy and paste?
Yeah, I can.
Does
do
anybody want to chime in?
I can do that. Just.
Doctor, I want to thank you on behalf of the chamber. It was extremely interesting and informative. I hope you would be able to join us for the condo. I think it'd be insightful to talk about this whole building management system idea.
I will certainly do my best to do that.
Jerry, do you have any other announcements before we close?
I want to remind everybody that the Celebrity Soccer League is happening this Saturday. Javon has been helping us put it together. It's open and free to the public. Games, I think, begin at noon. There are 4 matches, and as I say, it's open and free to the public. Should be a good time. Wish everybody a happy Thanksgiving.
Yeah.
We also have, sorry.
Go ahead, Danny.
We also have another program today at noon with Bimal, who is actually in the meeting and you have to step out. So it's a workshop, just like a leadership workshop about your business and how to improve it, and it's a great program. So you can join virtually or here at the chamber.
And we have tourism and hospitality Thursday at noon.
Yes, that's also here or.
All right, well, thank you, Doctor, for everything you've done for us today. We really, really appreciate it. Extremely
Thanks for
interested
inviting.
and very technical. I love it. I want to give special thanks to Dean John Stewart, who is a board member of ours, who is the one that connected me with you, and I want to give him a special thanks. Also, everybody that participated today, Jerry, and to Aaron for their leadership, and also thank you to you, Danny and Alicia, for helping us pull this thing together today.
Good job.
Hope everybody has a wonderful day.
Thank you, everybody.
Thanks very much.
Have a great day.
Just sign up.
I just sent you